So today is 10/8/18. Okay, number 3 on the 2C worksheets. Fastest speeds that traveled on land have been achieved by rocket cars. Current speed record is 1,090 kilometers per hour, which is 160 kilometers per hour less than the speed of sound in air. Suppose a car is capable of reaching the speed of 1.09 times 10 to the third kilometers per hour, and it's tested on a hard, flat surface 25 kilometers long. Car starts at rest, just reaches that speed when it passes the 20 kilometer mark. If acceleration is constant, how long does it take to make the 20 kilometer drive? So, what do we have? What do we have? Well, here, I'll go to the next one. So this is 2C worksheet number 3. We have VI, we have VF, we have delta X, we would like delta T. Does that begin to look like any equation that you have on your note card? Where's my note card? I've lost my note card yet again. You got anything on your note card that resembles that? Okay, so we've got the equation that we want to use. Delta X equals 1/2 VI plus VF delta T. Does that help? Is that what you needed help with, was picking the equation, or do we need to go further? Because we can. Go further? Okay, that is fine. So we know we're solving for delta T. I'm going to multiply both sides by 2 to get rid of my half. 2 delta X equals quantity VI plus VF times delta T. Still solving for delta T. And now I'm going to divide both sides by the quantity VI VF. When I do that, hey, look at that. I am solved for delta T. Was that what you needed? So that'll cancel that. Good?
I was good with that. It's just I was confused on what numbers.
Oh, okay. So that's where you have to stop me and go, Moser, the algebra's not my problem. I've got that. Okay, so what's its initial velocity? So this is a what the heck is VI? It's a reading the question problem. If the car, starts at what? Starts at rest. What's VI? 0. And they do this all the time. Starts at rest or comes to rest, and that's where you have to kind of automatically tie that to that is 0. Okay, you good with everything else? Was that the hard part? It always is. Yes, ma'am. Okay, so what do we have for VF? We have 1.09 times 10 to the third kilometers per hour. Delta X is 20.0 kilometers, and we want delta T. Now, right now, doing this, we're going to get an answer in what units for time? Hours. So the answer on the key is given in seconds. Is that perhaps?
I don't know.
Okay. So let's go ahead. 2 delta X. Okay, so 2 times 20.0 kilometers divided by 0 plus 1.09 times 10 to the third kilometers per hour. Boy, that's messy.
I guess I converted.
Conversion issue. So yeah, you can do this in the units given and then convert your answer to seconds. You can do it in meters per second. That's fine. Okay, we good on this? Going once? Okay, so German stuntman Martin Bloom performed to the Wall of Death, rode the motorcycle for 7 straight hours on the wall of a vertical cylinder. Average speed was 45.0 kilometers per hour. In a time interval of 30.0 seconds, he increases his speed steadily from 30 kilometers per hour to 42 kilometers per hour while circling. How far does he travel in that time interval? So what do we have? We have VI, we have VF, we have delta X, we have delta T. Well, actually, we don't have delta X. That's what we'd like to know. So delta T is 30.0 seconds. VI is 30.0 kilometers per hour. VF is 42.0 kilometers per hour. So once again, we're looking at this equation, and we're not talking about this one yet. Do I need to go further? I'm not sure whose this was. Was picking the equation the hard part? Is it a conversion thing? Part that they're going to do to you here is they're giving you velocities in kilometers per hour, and they're giving you time in seconds, so you're going to have to do the conversion. 30 kilometers per hour, and I paused the recording and stopped, so all right, we've got that one. Let's look at 2D. U.S. Navy vessel floats on a cushion of air, moves as fast. Oh, it's a hovercraft. 1.7 times 10 to the second kilometers per hour. During a training exercise, the ship accelerates at plus 2.67 meters per second, so that after 15 seconds, displacement is 6.00 times 10 to the second meters. Calculate the ship's initial velocity just before the acceleration, assuming that the ship moves in a straight line. All right, so what do we have? Well, we know we want VI. We don't know what it is. We have a rate of acceleration. We have a time. Let's see, 2.67 meters per second squared. And delta T equals 15.0 seconds. We want VI. And we have delta X. 6.00 times 10 to the second meters. Well, this looks like a job for VI, whoops, delta X equals VI delta T plus 1/2 A delta T squared. For no rational reason whatsoever, my favorite equation. Does that help? Do we need to keep going? So at this point, all of our units match. We're in meters per second squared, seconds and meters. And we have to rearrange for VI. Do you need help with the rearrangement?
No, I didn't have this equation.
Oh, okay. Cool. That was easy. Anybody else want me to keep going? We good? Yeah?
I got my...
Okay, so you're going to... Actually, you know what? Do you want me to give you... We've got 22 minutes. Let me give you 5 minutes to wrap up where you're at if you were on a problem and you still need time. And then we're going to derive the last of the kinematics equations, which means then that you can start working on 2E. I know you've been like a flutter all weekend, so excited to start working on the next set of problems. So I'll give you a few minutes to wrap that up.